Well, we're back here at the Cave of Science, and we're looking at the last three problems in, what worksheet is this? Unit 5, worksheet number 2. So we got some lead chromate, PbCrO4, lead chromate, was used as a pigment in paints. How many moles of lead chromate are in 75 grams of lead 2 chromate? And how many atoms of oxygen are present? Alright, again, we need to go through and find the formula mass of lead chromate. So we got Pb, we have 1, chromium we have 1, and oxygen we have 4. Lead's pretty heavy, so it's 207, so that equals 207. Chromium is 52, so that's going to equal 52. And oxygen is 16 times 4 equals 64. And if we add that together, come out to 323. Well, kind of the same type of problem. We got 75 grams. So we have 75 grams of Pb lead chromate. And again, I like to put that over 1 times 1 mole of lead chromate is 323 grams of lead chromate, CrO4. And if my math is right, that should equal approximately 0.23 moles of lead chromate, PbCr4. Put a line there so we don't get those mixed up. And then it says how many atoms of oxygen are present. Alright. I don't know if this probably won't get asked on a test, but it's kind of a fun problem to do. And so we've got 0.23 moles of lead chromate, PbCrO4. And again, I like to put that over 1. Now we want to get the atoms of oxygen. Well, this is a molecule. So let's start it with that. And if we got a molecule, you can only use Avogadro's number. So 1 mole of PbCrO4. And got to use Avogadro's number, 6.02 times 10 to the 23rd. And wait, this is a molecule, so we can call this a molecule. And again, it's PbCrO4. I'm kind of running out of room, so I'm not going to put that up there. Well, then we got to go back to the formula. In 1 molecule of PbCrO4, if we look at the formula, we've got 4 atoms. So we have 4 oxygen atoms. And that's what we want our answer to be. So we got this many moles. Moles of this are gone. Molecules of this are gone. So we're left with atoms of oxygen. So if we go ahead and do the math, and I'm just going to bring it down here, we find that there's 5.59 times 10 to the 23rd atoms of oxygen. Kind of a little different problem. I'll admit I probably would not ask this on a test, but it's kind of a fun one to do. Alright, let's look at number 10. And it talks about the diameter of tungsten. Oops, let's see if I get this up there for you. And so we got some room. Objects I've just flipped around. That would be just as easy. The diameter of tungsten wire in a light bulb is very small. It gives you some information. It says the mass of the filament is so small, 0.017 grams, that would take 1,600 filaments to weigh an ounce. Well, how many tungsten atoms are in a typical light bulb? So again, tungsten has a symbol of W, and that is tungsten. And that really, the W is from Wolfram, and that was the city, and I believe it's Norway, where they mined a lot of these metals. So let's go ahead and pretty typical problem. We got 0.0176 grams of tungsten all over 1. And we know in 1 mole of tungsten, and if you look up the atomic mass of tungsten, you'll find that it's 183.4 grams of tungsten. And we want to know how many atoms. Well, there's that term atoms, so we're going to use Avogadro's number. In 1 mole of tungsten, there's 6.02 times 10 to the 23rd atoms of tungsten. Well, if we go ahead and do the math, and I'll bring that right down here, we're going to see that it's 5.8 times 10 to the 19th atoms of tungsten. So again, a very, very small mass still has a whole lot of atoms on there. Alright, let's look at the next problem. And we'll fold my paper over here. And we got 2 popular antacids, are Tums and Maalox. The active ingredient in both of them is calcium carbonate. And they talk about Tums, they give you some mass, and Maalox, they give you some mass, and compare the number of formula units on this. The formula units, really, you're going to end up having to use Avogadro's number here. So just remember that when you look at that. So let's look at calcium carbonate. Again, we got grams. We're going to need the atomic mass, or the mass of the compound. So we got calcium, which we have 1. We've got carbon, which we have 1, and oxygen, which we have 3. Calcium, again, the periodic table is 40. Carbon is 12. And oxygen is 16, so that gives us 48. And it gives us a mass of 108. Alright, so we've got Tums. I guess we'll just put Tums up here. And we've got 0.747 grams of calcium carbonate, CaCO3. And first thing we got to do, we got to change it to moles. Moles is that's what we need to change things to work with anything. So 1 mole of CaCO3 is 108 grams of CaCO3. Alright, but we want to know formula units, so we're going to have to use Avogadro's number here. And we know in 1 mole of CaCO3, there's 6.02 times 10 to the 23rd. And see, I'm running out of room. I'm writing formula. I'm just going to put down units up here. Units of, again, that's going to be calcium carbonate up here. So if we get the answer, which I'm going to bring down here, is 4.2 times 10 to the 21st units. So there's our Tums. Well, let's look at our Maalox. Really, we're doing the same problem over again here. So with Maalox, we've got 0.747 0.600 grams of CaCO3, and we're going to set this up the exact same way, times 1 mole of CaCO3 is 108 grams of calcium carbonate, and we want formula units again. So in 1 mole of calcium carbonate, there's 6.02 times 10 to the 23rd, and again that's going to be units of CaCO3, and if we do the math, that comes out to be 3.3 times 10 to the 21st units. And it says compare the number. Well, this one's about 1 1/4 times as much as this one. We both know they're both 10 to the 21st. We can probably eliminate that, and we can go 4.2 to 3.3. 4.2 divided by 3.3. Yeah, it's about 1.27. So the Tums has about 1.27 times as much of calcium carbonate as Maalox. Oops, I guess I better push that up there a little bit. So that's where that one stands. And that is the last 3 problems on this.